Okay, so this morning I'm going to talk about elimination. Okay, elimination is a process of getting the other way. Now, for example, here's a little clue. Okay, a little mathematical thing that helps. If I take a number, 6 plus 2 equals 8, and another one that has like 5 plus 4 equals 9. If I add these equations together, I get 11 plus 6 equals, and these both equal 17 going both ways. Okay? So you can take an equation that's true, add it to another equation that's true, and get a third equation that's true. Now we're going to use that idea for elimination, because if I take these numbers here, if I got 3 plus 4 equals 7, and I do 7 minus 4 equals 3, then when I do these, if these are the exact same opposites right there, then I'll have these add together be 10, this becomes 0, and this equals 10. So I can eliminate this one variable. This is what the elimination does. This takes one of the variables and gets it to eliminate. So once we eliminate the variable, okay, then I can solve it, because one variable equation is easy to solve. So what we look for is we look for a set of opposites, just like this, where we have a negative 3x and a positive 3x, okay, combined here. Those are opposites. We want those to, when we add those together, it'll eliminate that variable, and we can solve for the other variable, and then come back and use it. So this is how, this doesn't work for substitution, but this does really work for elimination. Okay, so here's what I mean. We take this, and the first thing we do is we make sure they're in standard form. Okay, so we want to make sure that they're in standard form. Okay, that standard form is ax plus by equals c. That's standard form. Okay, and the second thing we do is look for what we call opposites. Okay, and so I have opposites right here. So the third step I'm going to do is I'm going to add and solve. So we're going to add the equation together and I'm going to solve. Okay? Now, so what we do is draw a line across here. We take negative 3x plus positive 3x. This is 0, so we just got to throw those away. And I take this positive 2y and negative 3y, add those together to get negative 1y equals, and then 11 minus 18 is negative 7. I have a very simple equation, never left to solve. I divide by negative 1 both sides, and I know that y equals 7. So I know my first answer. Okay? So I've done my add and solve. And my last step I do a sub and solve, which means I take, okay, this number, I will go back to the equation, find me y, either that y there or that y there. I think I'll do the bottom one, just for fun. It doesn't matter which way you pick. And you stick that in, you go 3x, take the whole equation, minus 3 times y, and y in this case is 7, equals negative 18. And you solve this equation. Okay, so I get 3x, this is negative 21, this is negative 18 still. If I add 21 to both sides, I get 3x equals 3, divided by 3 I get x equals 1. So my solution is 1 and 7. Okay, so that's how we do this. We set up like that. Okay, so we first when we eliminate a variable, solve that variable, then we take it and sub that back in and solve it, and present our answers. Now some keys to this, I'm going to change this a little bit because I don't do all these steps. Okay, well that was bouncy. Okay, is that we only add. In my classes we only add. So we can add as required. So we're going to take the subtraction, we're going to take it out. So we add the equation together. Always make sure both equations are in standard form. And all this stuff, we're not going to do this, we're going to add a new line here. Okay, so throw all that out. We don't subtract. Okay, what we do is we say that You must have opposites. So you need opposites. Okay, you need opposites. And opposites are a negative and a positive of the same number. Right? They can be either in the x variable or y. The x or y variables. And if you don't have opposites, then you get to make them. Okay? And we can solve, let's say, either x or y can be eliminated. Alright, so we're going to go practice this now. Okay, so on page 2. Okay, get this up here, we can look at it. Okay, here's my equation. Alright, the first thing I want to do is I want to check and make sure that they are in standard form. So 1 is standard form. Okay, SF, standard, that's SF. Standard form. Okay, pen drags. Alright, so they're in standard form. So the x and the y on the same side, 2's on the other side, that's right. X and y on the same side, these are lined up nice and pretty, so this is what I want to see when I get started. Okay, step 2, do I have opposites? Okay, alright, I don't have opposites right now, because these are never going to be opposites, they're not the same number. Okay, so for this purposes, they'll never be opposites. Okay, and these might be opposites, but they're both positive, so I need to make one fixed. So to change this, I have to make it, and to make it, I just multiply by -1. And what that does is it flips the signs for me. It doesn't matter which equation you take. So if I take the top equation, multiply it by -1, I get -5x. -1 times 4 is -4y. And -1 times -2 is +2. Then I take the bottom equation, and I have 3x. I didn't change it, so 3x plus 4y equals 10. Now you don't need to change every equation. You only need to change the ones that don't have different signs right here. Now it could be the x, or it could be the y, but they've got to be different signs. Okay? So now they have different signs. I have a +4 and a -4. So now I have opposites. So once I have opposites, I add and solve. Okay, so here we go. -5x plus 3x is -2x. -4y, +4y is 0. Those go away. And equals 2 and 10 is 12. So once you get that done, you finish solving the equation. So divide by -2. And you get x equals -6. Okay, so the second step then, the last step, is to put this back in here and do a sub and solve. That means find where there's an x to put a 6 into, a -6. So I go back over here, I can put it in that x, or I can put it in this x. It doesn't matter. I'll just do the bottom one just for fun. So I'm going to put 3 times -6 plus 4y equals 10. So I'll solve this equation. So it gives me -18 plus 4y equals 10. Okay, if we add 18 to both sides, I get 4y equals 28. I divide both sides by 4. I get y equals 7. So my solution is -6 and 7. Okay, and we're done. Okay, so 4 quick steps. Make sure it's standard form. Get opposites. If you don't have opposites, make them. Okay, and once you get the opposites done, add the equation together and solve them. And when you get that one solved, take your answer, sub your answer back into your original equations, and solve that for the next answer. Okay? All right, now, this last part is, we talked about this before when we did the graphing, when we said, hey, there's 3 ways you get systems. The first way is to have the 2 lines cross. Okay, and you get one solution. Okay? Those show up when you have this kind of thing going on. When your variables are hanging around, we do elimination, your variables stick around, I can solve for a number. This is one unique solution. This is what's going to happen, okay, when the lines cross. Okay? The second thing that's going to happen is the line's going to be on top of each other. Okay? You'll have infinite solutions. Now, when that happens, you do elimination on this. What's going to happen here is I'm going to have a positive 2x and a negative 2x. Those are opposites. They'll go to 0 when I add them together. On the y's, I have a negative y and a positive y again. Those are opposites. They'll add together to get a 0. And on this side, I get a negative 9 and a positive 9. So everything has disappeared. I get 0 equals 0 as my answer. This is a true statement. Okay? And that means that these equations are exactly the same equations. So that means that this is true. Anytime I get a true statement, 0 does equal 0, has infinitely many solutions. That's when the lines are on top of each other. Okay, the second scenario is when the lines are parallel to each other. They never cross. There will be no solutions. Okay? So in that system, in that event, we have kind of the same idea. We go to do our elimination, and my x's eliminate, become 0. My y's eliminate and become 0. But my constants don't eliminate. They become 9. Okay, or something like that. And I get 0 equals 9, which is a false statement. All my variables are gone, so it's false. When that happens, it's false. Okay? And then this means there's no solutions. Okay? Alright, so there's the gist of it. So we have 3 ways to get one solutions when you have variables. Variables stick around. Your variables, as long as you have variables, you have a solution. So this is always one solution, okay? If your variables disappear and the answer is true, then it's infinite solution. Variables are just gone and it's a false statement, and this is a false statement, so this is no solution. Okay? Alright, happy good luck at going on to elimination.